Alright, we're going to try our first calculus lecture online, and this is going to be on functions and their graphs. Seniors, so here it is. Here's what we're going to work on in just this little video here, is using function notation to both represent and evaluate a function. You guys are very familiar with functions, having talked about them a lot in Algebra 2, and we dealt with function notation a lot in pre-calculus as well. We're also in this series of videos on functions and their graphs. We're going to look at the domain and range of functions. Everybody's favorite two words, domain, range. We'll talk more about what those mean. We're going to sketch graphs of functions. We're also going to identify different types of transformations on functions, and then be able to go ahead and combine them and classify them in different ways. So that's what we'll be doing in this lesson on functions. Alright, the first section that we're going to cover in this video is functions and function notation. So the difference between, there's two words we need to get familiar with, a relation and a function. Relations are any ordered pairs, x and y, and we were talking about two sets of numbers. You probably remember the mapping diagrams. I have a big set of numbers, x, and a big set of numbers, that's y. And a relation is simply taking a member or a number that's in the set of numbers x and mapping it, or doing something to show that it ends up being a part of y. And so every x, so if I have a dot over here, that's x, and I take that, and here's a dot, that's its corresponding coordinate y. The function, or the relation takes it from that set to the other set. And so little x is a member of the big X set, and then y is a little member of y. Now, to be a function, functions are slightly different than relations, is that the big numbers x and y have the same property, that any two ordered pairs with the same x value also have the same y value. So if you guys remember the vertical line test, I'll show you an example of what I'm talking about. Here is an example of a function, a parabola, because every x value, as I'm drawing these vertical lines in here, only has one y value. Here's an example of a graph that's not a function, a sideways parabola. If you look, I have two different y values for this same x value right here and right there. So that's just reminding us what function is and what a relation is. They're very similar, but the difference is functions always pass this vertical line test. Variable x is the independent variable. We also call that our input many times, and then the output, or our variable y, is our dependent variable. Alright, so here's a little bit more of what we were talking about. Definition of a real valued function. We're talking about things in the real numbers. So again, guys, you have two sets of numbers. Here's our big set x with our inputs. All of the numbers in x in this blue circle here are part of what we call the domain, our set of input values. And then if you guys notice, the function f is like a machine that does something to these numbers. So it transforms them into a different set of numbers, and we end up getting our y values. Now, if you notice, this light pink circle here, as I'm moving the circle around, is inside a bigger circle. If you remember from Algebra 2, we called this big circle the target, and that's the types of numbers we're working with. And then the range is the actual outputs we get. And so here I'll draw an arrow, and I'll write, it's going to be a little messy, outputs. And so when we're talking about range, we're talking about the y values that we get from the equation, or the outputs that we actually see for this real valued function. And so we say that it is a value of f at x, or we read y equals f of x. This is not f times x, it's f of x. Alright, functions can be specified in a variety of ways. This is just some terminology and notation. It says, however, we'll concentrate primarily on functions that are given by equations involving the dependent and independent variables. For instance, the equation x squared, so here's an equation we're going to work with a little bit today, x squared plus 2y equals 1 is called, it's an implicit form because you'll notice both the variables are part of this side of the equation. It says it defines y, the dependent variable, as a function of x. So this is an equation in implicit form, that y is kind of implicit or implied. It's part of this side here. So we'll switch, and now we're going to look when you solve that equation for y. So we start with x squared plus 2y equals 1. That was our implicit form. And now they're going to go ahead and rearrange that equation to solve for y. It says to evaluate this function, that is to find the y value, it's convenient to isolate on the left side of the equation. So you see they solved it for y. And again, the way we do that, they're going to subtract x squared from both sides. I'm going to go through this relatively quickly. Minus x squared here. And so then you end up with 2y equals 1 minus x squared. And then they divide it by 2 to get that part. So it says using f as the name of the function. So you'll see they just replaced y with f of x. So here they're the same thing. They're just renaming it as in function notation. So we say f of x equals 1/2 times the quantity 1 minus x squared. What this does is it explicitly defines y in terms of x. So now I have an equation where I can put in or input any x value and figure out what f of x equals at that location. When you solve for y, you're writing the equation in explicit form. And so when we write explicit form, we're solving for y. All right, here's some examples that we're going to go through. Here's our equation. We read this, f of x equals x squared plus 7. And it says evaluate each of the following expressions, f of 3a. So here's the first one, f of 3a. So we know that f of x equals x squared plus 7. And so f of 3a, everywhere I see an x, I'm going to replace it with a 3a. So f of 3a is going to be equal to the quantity 3a squared, make sure you get that parentheses in there, plus 7. All right? And I'll click ahead and we'll look at what this does. It's going to be neater than what I've written it as here. All right, let me see if I can get this erased out. Make my stuff disappear. It's not going to. All right, guys, sorry about that. So you've got f of 3a squared plus 7. So 3a quantity squared is going to give us, I'll click ahead and you'll get, so you substitute a 3a for x. So 3a squared, if you see under there, you got 9a squared. 3 squared is 9, a squared is a squared, plus 7. And so you end up getting, I'll bring up the last one. So you get 9a squared plus 7 for that one. Now in the second one, you'll see they have f of b minus 1. And they replace, where you have an x, you're going to replace with b minus 1. And then you're going to go ahead and multiply out. Nope, we lost it there. See if I can click ahead. There we go. All right, so they take b minus 1. The way they get here, this part comes from multiplying b minus 1 times itself. You can FOIL it. You can use the boxes. Put a b minus 1 on the top. And on the side. And you all should be good at this by now. B minus 1 times b minus 1 gives us b squared minus 2b plus 1 plus 7. And then finally simplifying it. Keeps going back to the same one here. Bring it up one more time. And we'll go to the next slide, hopefully. There we go. So they just combine the 1 and the 7 to get 8. and that is simplified. And we'll look at this one together in class. So I will actually pause it right there. We'll talk about this one in class, but you can look at the solution. It's also in your book.